Section 1.3, collecting sample data. And so we will look at different types of sampling techniques: convenience sample, voluntary response sample, random sample, a simple random sample, somehow that's misspelled, a simple random sample, it's not supposed to be random, so simple random sample, systematic sampling, stratified sampling, cluster sampling, and then using multiple of these, of the above, the multi-stage and sequence sampling. Okay, so why do we sample? So we sample because, well, it saves both time and money. If you look at the United States, we conduct a census every 10 years. I think it was Jefferson. So I believe it was Jefferson who was initiated doing the census. And so we do this every 10 years. And well, there's a gigantic department that does census, having varying numbers of, well, they have a whole bunch, like, I don't know, 100,000 or something, a lot of employees and a lot of temporary employees in order to do this. So it costs a lot of money. And to conduct the US Census, it takes basically 10 years. So it's a this is why it's permanent. They have permanent jobs. It takes basically 10 years to do this. There are, I believe it takes around 3 years to actually conduct the census. It takes another 4 years to analyze and publish the results. It takes another like 3 years to get ready for the next census. And then you start out the whole process yet over again. So it's a full-time job because it takes you basically, every day to do some part of this process. So there's always something that needs to get done for this census. Not only that, it enables the researcher to get information that he or she may not be able to obtain otherwise, because you are asking everyone in a census. You're not going to be able to ask them everything you want. In a census, usually you're only asking them like 10 questions. The matter of fact, to add or subtract a question is a process that's very difficult. Trying to add a question or subtract a question to the census takes a while. Matter of fact, up until recently, I don't think it's still asked. They used to ask you if you had a toilet. That was much more important around the turn of the century, when very few people, meaning like 1900, like in the 1700s, 1800s, early 1900s, where very few people had things like a toilet inside of their home. Currently, obviously, most people do. Even though neither of my parents did, but none of our parents had running water, or any of their relatives even before them. But it enables researchers to get more detailed information about a particular subject. So you can ask very detailed questions if you're only asking a very small, select sample of people. So first, a convenience sample. So Here's an example of convenience sample. A convenience sample is one where the results are easy to get. So here you are. Here is your respondent. A voluntary response sample is one where the respondents decide to if they're going to respond or not. Such as, let's say, if you're listening to a program on, the television, and during this program, say it's some political program, they ask viewers to respond to a poll about about the subject that they're talking about. The people who respond to the poll are just those people that call in. So the way that, they do the sample is they ask people to call in. So that's a voluntary response, a self-selected sample. You are selecting whether you participate in this particular sample or not. Not the researcher, it's you that's determining this. A random sample. Now, in this course, we're really only going to be looking at random samples. Why? Because all of our techniques depend upon having a random sample. In your other courses that you'll be taking, what you'll notice is that even though all techniques are done through random sampling, you actually usually don't do random sampling just because there are many reasons why you wouldn't in the field. So in the field, when you go out into the field, it may be that it's impractical to do a random sample. Okay. But in this course and in almost all, not quite all, in almost all of the techniques of statistics, it is assumed we have some type of random sample, or at least a representative, or for some of these newer techniques, a representative sample of the population. So somehow getting a representative sample of the population. Easiest technique, of course, is a random sample. So a random sample is one that's obtained using these chance methods. It used to be that there were tables that were utilized in order to randomly pick someone, or they used to have mechanical devices, such as, when you look at the lottery. So if you ever look when they pick numbers for the lottery, that's done not through the computer, it's done through a machine. They have, ping pong balls, it's not a very sophisticated machine. These are the old ways that people used to do random sampling, is they mix up, in this case, a whole bunch of ping pong balls, and they arbitrarily choose one of the ping pong balls. And so, you arbitrarily pick a marble from the bag of marbles or whatever. Currently, we usually do just computers. So computers or calculators, you can do this on. So a sample is a random sample if every member of the population has an equal chance of being selected. So members from the population are selected in such a way that each individual member in the population has an equal chance of being selected. Now the question is, well, what is a disadvantage of a random sample? So one of the disadvantages is that if the population is large, it can be quite time-consuming to number and select the sample elements. So it could be that every member in your population is not numbered. So how do you number everyone in your population? If you have, say you're doing something in India, so you have like 1 billion people, trying to number, 1 billion people is not so easy. And trying to then select them is also not so easy. So there are differing types of random samples. The type of random sample that we will be looking at is a simple random sample of size n. So usually, actually, let me put a subscript here. So this is, well, so SRS sub n. So a simple random sample of size n, denoted by SRS sub n. In a simple random sample of size n, this is a sample of size n in which every other sample of size n has an equally likely chance of being selected. So every possible sample of size n has the same chance of being selected. There are two different ways of doing a simple random sample. I can do a simple random sample with replacement of size n, or a simple random sample without replacement of size n. And so in a simple random sample with replacement, this is a simple random sample of size n, such that every member of the population can be selected yet again to be in the samples. So well, you can think of it this way. Suppose that I am choosing some people, let's say, some students. Suppose I'm selecting some students. I then pick the first student. After I've chosen the first student, I then have the student sit back down. I then again do a random selection where again I'm randomly choosing. And the person who just sat down can still be in the same sample or in another sample. And so once I've chosen a particular member to be in a sample, they're free to be in yet another sample. And so it turns out that it acts as if every population is infinite, because you're always able to pick a sample. Let's say I have 2 students and I want to pick a sample of size 4 from these 2 students. I can do that I can do that as many times as I want, because I pick the first student, I pick one student. Okay, that's a member of the sample. I have them sit back down. I then choose again. So I can keep choosing. So even though, say I'm choosing even a sample of size 4, I can still do that from 2 students because I keep having them sit down every time. And so I can choose with a simple random sample with replacement any number of simple random samples with replacement of any size I want from any population size. Because it acts, the population size then acts as if it were infinite. Next, a simple random sample without replacement. So now let's try to do this without replacement. So it's the same as a simple random sample, a size n, except in this particular case, what we're going to do is once you have been selected, that's it. So let's do the same situation where I am choosing students. And so what I'll do is I'll pick a student. I'll have them come to the front of the class, but then they can't sit back down. So I'll say, okay, well, that's all nice and fine that I picked you. But once I picked you, you can't sit, you don't sit back down. You have been chosen. And so you're in this sample, and you can only be in this one sample. So once I've chosen you to be in a sample, then that's it. You're in that one sample. So therefore, in this particular case, I can't keep going on and on forever. Once if I have a finite sample, if I have a finite population, then eventually I run out of subjects to put into my samples. So let's say that, I have like the same situation. I have like 3 students and I do I want a random sample. Well, I can only have, as many as, a sample of size 3, and I can only do that once. I can't have more than one sample of size 3 because that's all the number of people I have. So in this particular situation, I can just have a few people of a certain sample size. Okay, here, wait one second. See if I can log on to this. Let me not talk for a second because I have to turn this off.
This meeting is being recorded.
Okay. Oh no, I gotta do this too. Okay, now that should be okay. Okay, sorry. I was trying to go to my other computer. Because like right now, I want to see if I can find this. Sure, you had to do this on a TI, here it is, TI-84. Okay, so let me try to change. Here's share screen. So I'm changing computers so that you can see this. Okay, good. You should be able to see this now. Let me just check. Yes, you can. Okay, good. So now, suppose I want to find a random number between 1 and 20. So let me use my TI-84 to find a number between 1 and 20. And so let me go to math. Let me go to probability. let me go to random integer. So, so let's say I want numbers between 1 and 20. So I'll do 1 and 20. Actually, I can even get rid of that. So I want a number between 1 and 20. And let's enter 19. If I did it over again, oh boy, doesn't 3, good. So usually it doesn't give me back the same number. So the first time I did it, I got 19. Second time I did it, I got 19 yet again. Third time I did it, I got 3. So it's giving me random numbers. But what you notice here is that it could give me the same random number. So I have here some random number between 1 and 20. Now let's do the same thing. A random integer between 1 and 20. Let me ask for 5 numbers between 1 and 20. So if I do that, I get 11, 9, 15, 1, and 7. Oh, this is the only time. Last time he gave me a repeat. Let's try it again. There, good. Notice that in this case, I could have the same number picked twice. So I have and a 5. I have a 20, 5, 16, 25. So notice that the 20 was chosen twice and the 5 was chosen twice. So it could be that rather than like here, they gave me all different numbers. It could be that, well, instead, we're doing it. So in this case, we're doing a random sample with replacement. So it means that the same number could be chosen more than once. Let's see if I can do Mathematica. Let me start up Mathematica here. Okay. Okay, so in this case, let's find a random integer. Between 1 and 20. 18. Let's find a random integer. Let's find several random integers. Oh no. A random integer between 1 and 20, let's say. I'll just say range 20. That's the same as saying between 1 and 20. And I'll say I want 5 of them. Okay. Oh, I know. Sorry. So I want a random integer between 1 and 20. So I want 5 of them. What you notice here is that I've duplicated the fact that, well, notice that I have 2 3s. If I want to do this without replacement rather than with replacement, then I would do a random sample. So I can do a random sample. I'll just do range. say 1 to 20. And I'll pick 5 of these. So this will always give you, so let's pick, notice if you pick, let's say 5 numbers between 1 and 5, then they work really hard. You'll never get a duplicate. 5, 1, 2, 3, 4. So no matter what, you're not going to get a duplicate if you say random sample. Let me do R. Here's R. Oh, wait. Let me do Excel. Let me do Excel. Where's Excel? I don't find Excel here anywhere. Why is Excel not here? Okay, let me do R. Okay, let's do R for a second. I'll have to figure out where Excel went. Oh, it's because I haven't said open yet. Okay. Let me do R. So for, let's be sure I picked R. Yes, I did. Okay. So for R, I could just say, well, let's do a sample. From 1 to 20. And I'm going to pick one number. So I'm going to pick one number between 1 and 20, 18. Or I could pick 5 numbers between 1 and 20, 22, 7, 12, 4. But again, this is not, of course, get it twice. These will not necessarily be, unless, let's see, I thought this was done it. Replace. Replace is false. Oh, that's the default is false. The default is false. Okay. Replace is true. Or 0. There. So if you, between 1 and 20. So if you did this, it's possible that I get a duplicate, of course. In all these so far, they don't have any duplicates. Yeah, whatever. Eventually, you could get a duplicate. There it is, finally. So if you say sample 1 through 20 and the replace is true, notice I have 8, 15, 17, 15, 14. So I have 2 15s. So this is with replacement. And if you get either write that as false or just get rid of it, this will give you without replacement. Oh, and I didn't do Excel yet. Let me do Excel. So Excel. Put equal sign, random, between. And let's say between 1 and 20. So let me get a random number between 1 and 20. And I want 5 of them. So you just drag, if I can drag this. There it is. And so I have 5 numbers between 1 and 20. And let's do there. Oh, there, I got a 4 twice. So notice that, and I got a 10 twice. So notice that in this case, I'm doing this with replacement. And it's kind of hard. In Excel, it's actually kind of hard to make it without replacement. And unless otherwise specified, well, let me go back to this other, let me go back. Unless otherwise specified, I will always assume, so unless otherwise specified, every sample in this course is assumed to be a simple random sample without replacement. Okay, so unless I tell you otherwise, make the assumption that we're doing a simple random sample without replacement. Next, systematic sampling. So in systematic sampling, you will just pick every, let's say, kth person. So you have everyone line up, and let's say I pick every 4th person. And that is systematic sampling. So I first arbitrarily randomly choose the 1st person. And then after that, I choose every whatever, 4th person. So if you've ever heard of the term decimate, has anyone ever heard of the term decimate? To decimate. The term decimate is a old term from back in Rome, back in Roman times. So Rome really did not have a standing army. What Rome would do is they would conquer lands. And after they've conquered a land, they would conscript everyone, all males, to be in the army. And so, in order to be sure that your newly captured enemy, who is now fighting for you, would actually fight for you rather than rebel against you or run away, from the fight, rather than fight your, whoever the Romans want to fight with. They would instill order by using the process of decimating. And in this process, what they would do is, if someone in the legion either ran away during the fight, or somehow refused to fight, or turned against the Romans, fought against them, they would arbitrarily pick one person in the legion, and then have everyone in the legion stand in order and stand in line. They would then pick every 10th person and have them executed. And so deci meaning 10. And so they would have the other people in the legion execute the every 10th person. So deci. That is a systematic sample. So advantages. Easy to select sample elements. It's every 10th person. It's every kth person. Disadvantages, it may be biased if the population is listed in a structured manner. Let's say that we look at married couples between males and females. And we have females, then males, lined up. And we arbitrarily pick someone and then choose every fourth person. Well, if I do that, then I'm always picking the same gender. And so that gives a biased sample. And so if there's any sort of structure in this, then it's going to be biased. So things like, suppose you are using employee numbers to order yours. Well, it could be that there's some structure to your employee number. It could be that some ranges are for a particular member of a particular department. And so because of that, then this scheme here would give you bias. Stratified sampling. So in stratified sampling, you will subdivide your region into strata. So somehow you're subdividing your population into strata.
Professor, I can't see your screen. I think it's still.
Oh no!
I think
Oh,
it's still in
no.
the Excel.
Oh no! Oh, I didn't say yes. I'm sorry. I'm sorry.
Okay,
Your
thank
screen.
you.
Oh, aha. Yes. Yeah. Unfortunately, when I switched over, when I switched over, it didn't tell me. The chat was over on the other screen, which I didn't see. Okay, sorry about that. Yeah, if that ever happened, please tell me. It's hard to switch between computers and screens. And voila. Okay, so I told you about systematic sampling. So in systematic sampling, you're just picking every kth person. So in strata, you subdivide your population here into a whole bunch of strata. A strata is a homogeneous characterization of your population. So everyone in this strata has the same characteristic. Everyone in this strata has the same characteristic of your population. So you will then pick an equal number of members of each strata to be in your sample. Now, let's say, so this is very popular amongst, let's say, political polling. So in political polls, they will somehow stratify the population. So let's see if I can remember the strata that they had. They're always very complicated. So if I remember, it was females, never been married, in near rural areas, northern Pennsylvania, with between 1 and 4 years of college education. Yes, I think that was the strata. So those voted all the same way. So that block, that particular block of individuals voted all in the same fashion. So you could treat all of those as being the same. And there are other strata. So I don't remember. They have these political polling, and they go out and spend exorbitant amounts of money to figure out strata. You know, how to look at a population where everyone in these particular, as much as possible, everyone in each of these strata all vote or do not vote in the same way as you know, as other people in this particular strata. So you try to make the strata as homogeneous as possible. So these are homogeneous class. These are homogeneous. Okay, then you pick a few of these. So you pick the same number in each of the strata. Now, great advantages. It ensures representation of all subgroups of the population that are important to the study. Disadvantage, it's impossible to do. If there are a large number of variables of interest, the task of dividing a large population into represented subgroups requires a great deal of information, a great deal of effort. And when I am really minimizing this, when I say great deal, I mean it's just gigantic, and it costs tremendous amounts of money, tremendous amounts of labor. And the problem is that, as with all populations, everything is always changing. So it's a ongoing, tremendous effort. Next, if the variables are somewhat complex or ambiguous, such as beliefs, attitudes, prejudices, it is difficult, if not impossible, to separate individuals into subgroups according to these variables. So in general, of course, another understatement, it's difficult to stratify a population. So it's a very difficult thing to do. So cluster sampling. So in a cluster sampling, we have here a population. We then look at some clusters. So these clusters here are these, and usually they're geographic in nature. So usually they're these geographic sort of entities where these are as heterogeneous as possible. They should be as heterogeneous as the population. So each of these clusters should be really a subset, this should actually look like, say if we're looking at the United States, then this should look like the United States. So if you look here, they should have all the same characteristics as the population. They should have the same variability as is seen in the population. You can then just take a few of these clusters, maybe just one of the clusters, and do your sampling in that cluster. And so the advantage is that, well, rather than going all around the United States, you just have to do it here. You just have to go to Peoria and look at that instead. And so cluster sample can reduce costs. It can simplify field work. You're only doing it here. It's convenient. So that's the advantage of doing a cluster sample. Now, the disadvantage, of course, is that, well, the elements may not have the same variation characteristics as that from the population. So it used to be that, well, in political polling, especially in the 1950s and 60s, they always used to go to one area in the United States, Peoria. Let's see, Peoria. Where is Peoria? I think Illinois. Peoria, Illinois, or Iowa. It's in the middle of the country. Somewhere in the middle of the country, they would go there because basically, you know, it was a very small town, a few thousand people, but they voted the exact same way as everyone else in the country. So since, you know, they always voted in the same proportion as everyone else in the United States, then they would go there and ask opinions about, you know, what they thought of political candidates, because they were the little microcosm of the United States. Now, of course, they're no longer quite the characteristics of the United States. It's a very rural community, extremely Caucasian, like 90%. And used to be almost 100% back when they were doing it in the in the 50s, 60s, 40s, 50s, 60s. So things like, well, key precincts. So currently, when looking at polling, it's like exit polls, they look at these particular precincts, which are called key precincts. And then do sampling within those clusters. So, oh, here it is. And in a multi-stage, we just use, well, several different techniques. So an example is exit polls. So in exit polls, you first find your strata, then you look at your clusters, your key precincts, and then from each of these, your participants are chosen using a systematic sampling. So I believe in exit polling, they choose every 15th voter. So they have at these key precincts where they've actually then look at a particular randomly chosen polling location. They then stop and question every 15th voter. And that is a systematic sampling. Then those results are shown on election day. So obviously this is done on, well, this is done on election day, where they then give the results and they show those on television. So of course they also, since, well, there were some problems where some of the polling was incorrect because of other factors. They also currently don't show the raw. So currently they don't show actually the raw exit polls data. What they show is the exit poll data, but then they also use the counted votes, which may be very small, but they may also include things like absentee ballots and other things and other polling data to modify the exit polls to give a more accurate representation of the data. So they use the exit polls plus other data to give a fairly good representation of the current state of how a particular race is actually, occurring, how many votes are actually being cast for a particular candidate or for a particular measure. Okay, so sequence sampling. So in sequence sampling, so this is usually used in quality control. So you have successive units are sampled. So say you have a production line. So successive units are taken from a production line to ensure that the products meet a certain standard that are set by the manufacturing company. So, you want to be sure that, if you look at this particular product and the next one, there isn't a huge variation between one and the next. If there is, your machinery is out of whack and you got to do something, so somehow they do these in sequence sampling to be sure that everything is running smoothly. Double sampling. So when you have a very large population, usually you have an initial sort of weeding out. So you have a weeding out process. So this is a way to sort of deal with large populations. So you give a questionnaire to determine those who meet the qualifications for the study. Then you pick from those your random sample. So you sort of weed it out by utilizing first one sampling technique and then utilizing yet another sampling technique to actually do the sample. And then a multi-stage is, well, like exit polls, we use several different sampling methods.